This is the second video for 7.3. We are talking about the basic probability principle, and the next one is when we use this formula when the outcome is equally likely. So if you toss a coin, if it's a fair coin, like the probability of getting the head and the tail should be the same, right? So if we are rolling a fair dice, we want to find the probability of this. So when you find a probability of an event, you will put number of favorable outcome on top and then number of total outcome at the bottom. The total outcome would be the sample space, right? So if I want to find the probability of rolling a fair dice and get a result of 3, I need to write it in this format, right? Probability of a 3 is going to be totally a dice of 6 outcome, right? 1, 2, 3, 4, 6, and then 3 I only have one of them, right? Not 3 out of 6. Okay, so one favorable outcome out of 6 total outcome, that would be my probability. And remember, probability is between 0 and 1, so 1/6 is an okay answer. How about probability of rolling an even number? So probability of an even number, that's the proper way to write it. Totally I have 6 outcome, right? And then even I have like 2, 4, 6, right? Sorry. So I have 3 out of 6. So half of the chance you can roll an even number when you're rolling a fair dice. Half, or like 50% of the chance. So either way would be okay. Less than 10, I only have 1 dice, right? So I can have 1, 2, 3, 4, 5, 6. But so probability of rolling a 10 is not really possible, right? So I have 6 possible outcomes, but rolling a 10 will happen 0 times. So the answer is 0. The chance of rolling a 10 from a fair dice is 0, right? There's no chance. Rolling an 8, I'm sorry, rolling less than 10, sorry. so if rolling less than a 10, that change everything, right? So rolling less than a 10. So I have 6 possible outcomes, but 1, 2, 3, 4, 5, 6, all of them are less than 10, right? So anytime you roll the dice, it's going to be less than 10. So the probability is 1 or 100%, right? And then rolling an 8. So probability of rolling an 8, not less than 8, but rolling an 8. I have 6 possible outcomes, but I don't have any 8s, so the probability will be 0, right? So you have 0 chance of rolling an 8. 0%, right? Okay. So that's the basic probability. How many favorable outcomes compared to how many total outcomes. Alright, so the next question, you can take a minute to write it down. They're doing playing cards. So I don't know how familiar you are with cards. They have 52 of them. A, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, king, and queen, right? And then you have these 4 type with these 13 different ones. And then you have half of them are red, half of them are black, right? So if you need a minute to write down, please do so. The probability of pulling a queen of hearts. So remember, the probability of the event is the number of favorable outcome compared to the total outcome, right? So totally, how many cards do I have? I have 52 cards, and then how many of them would be Queen of Hearts? So Queen of Hearts, I only have 1, right? So 1 out of 52 is my answer, and it's between 0 and 1, so I'm good. How about probability of drawing a queen? So again, I have 52 cards. How many queen do I have? Like I have queen of hearts and spades and all these 4, right? So totally I have 4. If I reduce it, my final answer would be 1 out of 13, which makes sense, right? I have 13 type of cards. How about probability of drawing a red card? So again, I have 52 cards. How many of them are red? 26, so divided by 26, both top and bottom. It means half of the chance, or 50% of the time, I'm going to draw a red card, right? Okay, and the next one is drawing a face card. What do they mean by face card? Face card would be all the jack, queen, and king, right? So I have 4 here, 4 here, 4 here, right? So totally I have 12 favorable outcome for face card. Compared to how many total card do we have? 52 total. So both of them can be divided by 4. Is it 4? So divide by 4, divide by 4. So I have 3 out of 13 chance of drawing a face card with a regular deck. Okay, so that may be some questions like this on the homework or test. Okay, this example has like some marbles in the back. 2 are red, 3 are blue, 1 is purple. So the first one asks, and again, if you need to pause the video and write that down, please do so. The first one say probability of pulling a red one. So I need the favorable outcome compared to the total outcome, right? Outcome. Okay. All right. So how many? How many red do we have? We have 2 reds, and then we have 3 blue plus 2 red plus 1 purple, right? So we have a total of 2 out of 6. If you reduce it, means 1 out of 3, right? So 1 out of 3 chance you're going to get a red marble. The second one, if you want to pause this and try that, you can. Favorable outcome would be 3 blue 1 compared to 6 total, right? So we have this, and we can reduce by 3. So that would be half of a chance, or 50% of the chance you're going to get a blue marble out of this deck. And the last one, say not blue. So what do they mean by not blue? So not blue means I have 6 total still, but I need not blue on top, right? So you can use 6 subtracting 3 blue, which is 3 out of 6 again. So if you reduce it, again, it's half of a chance, or 50% of the chance is going to be not blue, right? So you can think of it like that, or you know the other one is 50%, 100% minus 50% would be the answer for the next one. So that's how this works. Hope that makes sense. The very last part, it talk about empirical probability. They say in real life, and again, if you want to pause and write it down, please do so. It may not be possible to set up the exact probabilities for the events, like tossing a coin, head and tails. Like you can set up, but some other events you may not be able to. So they say instead, they're going to use past experience to draw approximation for the probability. So this type of probability is called empirical probability, and the way they do it is they want to see number of events occurred compared to number of time the trial represents. So it could be like a clinical trial, stuff like that, real life stuff. So the following, you want to decide they are empirical probabilities or not. So the first one say the probability of heads if 2 consecutive coin toss occurred. So you can actually toss those coins. So this is not an empirical probability. So the next one say the probability of a person getting lung cancer for smoking. So this one is not something I can set up, so it would be basing on the past data. So this one, yes, it's empirical probability. So hopefully that makes sense to you. And some of your homework question may ask you that.